This is the real Tom Rose, and we're doing a counting problem here. You can tell it's a counting problem because they ask you how many. Now, what we ultimately want to do is come up with some final total. And you can tell by the answer choices that it's a small enough number that we could actually just count. And that would not be a bad strategy. I assume you can count on your own. So what I'm going to show you is the general strategy for these problems, which you can use again on problems with larger numbers that you could not manually count. Now, this problem meets two interesting criteria. We have constant number of decisions, and we have a constant number of choices per decision. For example, we're asked to pick one style and one size for every combination. And notice that we were always picking two different things. So there are always two decisions. You always must pick the style and you always must pick the size. So we have constant number of decisions. Also notice that no matter what we pick in our decisions, for example, say I start out with boot cut. In the second decision, I will always have 4 choices. So we'll start out with the first decision, we'll have 3 choices. Then we will have 2 choices. So that criteria is also met. Anytime both of these criteria are met, we can use a very fast simplification for counting, which is you take the number of decisions, there's 2 decisions, you take the number of choices in each decision, 3 choices in the first decision, 4 choices in the second decision, and I labeled that wrong before, that should have been 3 and then 4. 4 choices in the second decision, you multiply them together to get 12, and that will be your answer. So you just multiply choices in every decision, and that'll give you the total number of combinations.